Okay, so let's review exponent rules. So first we should maybe put in our brains how many exponent rules there are, so we know when we're missing them. So how many exponent rules are there?
5, 4, 6.
I know there's at least 4.
A whole bunch, maybe.
Yeah.
Okay, there are not so many. They fall into roughly 3.
Oh.
But there are some more you can write. Okay, so the 3 that I kind of think of personally are if I've got, maybe let's do this way. Let's do, I've got x to the n to the m. What do I do with the mul?
You just said
Damn it.
Okay.
Okay. On this one, I multiply the exponents. So I get n times m. Then there's this other one about x to the n times x to the
N or M?
m.
Just combine them.
And this one you
Just combine.
combine, right? By
Adding
adding.
or subtracting in quotations. Like.
No, this one's strictly adding,
Oh, yeah.
right? But if m is negative, then it turns out to be subtraction, right? You guys see that? Like if I'm adding a negative number, that's the same thing as subtracting the absolute value of that number, right? Okay, so I would think I've got this one, the multiplication one, I've got this one, the addition one, and then there's this other one that's a little bit nebulous, which is, yeah, negative exponents belong on the other side of the fraction bar, right? And the way I personally think about this one is just to say that x to the minus 1 is 1 over x.
Can you go over why 0 to 0 is undefined again?
Yeah. Okay, so there are these guys, right? These are my kind of basic exponent rules. And then there are some things I should remember about exponents, which are that zeros to numbers is
0.
0, because I'm multiplying zeros together, right? What's 0 to a negative number?
0.
No, it's 1. No, it's undefined.
Remember, negatives mean it belongs to the other side of the fraction bar. So that's undefined because I'm dividing by 0, right? So really what I mean here is this number is positive, right? Okay, so I've got this kind of rule. Zeros to numbers should be 0. And then I've got this other rule that numbers to the 0 should be 1. Because
Like no matter what the base number is, it's always
yeah, except for
0.
0, because that 0 should follow both rules, right?
Yeah, but it can't. So.
Right, so if I think about 0 to the 0, it should kind of fall into both of these rules. So like thinking about this one, I should have 0. Thinking about this one, I should have 1.
But also, if you have 0 things multiplied by the same amount of 0 things, you still have 0 things.
Yeah, this is a good way to twist your head off, is to try to write a story about 0 to the 0. I would advise against it because it means that you're trying to represent it as both 0 and 1. It can't be. So this object is not defined.
So
There's maybe a good reason to think that this rule takes precedence there, but that's a calculus topic. What's up?
if we like draw that kind of, that's an answer.
Yeah. Yeah, or you could say like, okay, here's rule A and rule B, right? 0 to the 0 should follow both rule A and rule B, and it can't because they're different.
Right.
Cool. All right. Do you guys want to play with an example, or was this enough exponent rule review?
What about exponents and fractions? Like, how do you
Can we do
handle
a
those?
really nasty one?
Yeah, so one thing we
The
could
kinds
think.
that I put on the last test.
Okay, so do you want me to make one up?
Sure. Whatever your heart desires.
Okay, so I'm not sure whether you mean that we want exponents on fractions, or you want to do exponents when there is a fraction, so I'm going to do both.
Okay.
It's going to be horrible. We'll get over it.
See, I already know. Already. Kind of invisible pain.
Okay, so this is horrible and scary, right?
Oh my gosh.
All right.
Oh my gosh.
Oh my god.
Well, I like, that's just one.
Oh yeah. Okay, so some of these we can deal with right away, right? Like what?
Like the one.
Well, you could just move the Z out.
Is there one?
Okay, so I just flat don't need that thing, right? Because that's multiplication by 1. Quite a lot. Okay. So then what else might I do here?
You can move all your negatives.
Everything up and change
Switch.
signs and how you see it.
Okay, we could move everything to the top and just change all the exponents to negatives. Or we could reposition the negatives to their kind of appropriate place. I'm going to advocate actually for the move everything to the top, change the exponents to negatives, and then sort it out. Okay, so I've got a half cubed, a third cubed, x squared, y to the minus 2, x to the 5th, and then what else?
You have -8. Oh, it's on exponent, by the way.
So I have 8.
A third to the negative.
So I have 8 to the -1, right? And then I have a third to the -2,
Y to the +7.
y to the 7th,
10, x to the 10th,
x to the 10th,
and then z to the 50,147.
and then z to this big number, right? Which is just a number, right? Okay, so now what do I do?
You can
Combine my terms.
Yeah, we're really combining like terms with multiplication, right? So, okay, here's some y's. Wait, do I want to start with y's?
start with
Yeah, you
x's.
can start with that.
Doesn't matter. You can just do whatever.
Okay. Maybe philosophically, I'll start with x's. Okay, so what am I doing with the powers on the x's?
You're just adding them.
Adding them, right? I'm following this rule. Okay, so what have I got on x's?
You have 17.
17. Okay. That's x's. What's next?
Y's.
Okay, y's. So there's some y's.
You get y to the 5th.
So I'm adding again, right? And that's y to the 5th. Okay.
And Z.
Oh yeah, z's easy, right?
Z to the 50,000.
There's just a 1. It's got this horrible exponent on it, right? But it's really just a number, and it's kind of a big one, but whatever. We'll just write z to the 50,147. Whatever. It's a lot of z's multiplied together. Notice, that's a much easier way than writing 50,147 z's all multiplied together, right? We'd still be writing tomorrow on that one, and we'd probably lose count, which would suck, because then we'd have to go back and count however many z's we've been writing. All right, so I've taken care now of x's, y's, and z's.
Then 8 to the -1.
Okay, I can do a bit better than just putting the 8 to the negative 1. That's, yeah, it's 1/8, or I could put it back in the bottom, right? Let me leave it as an 8. I'll just deal with all the fractions together. So let's see, that's dealing with this piece. So I've got an 8. Okay, what else do I need to sort out?
You can combine the 1/3 together.
Oh yeah, I can stick the thirds together. So there's
Just
thirds and thirds. So I've got
just 1/3.
1/3 to the 1, right? Which is 1/3. Okay, and then there's a half cubed, which is an 8. You guys see that? Kind of off to the side, I might think to myself, got a half 3 times, right? That's an 8. Or I might think to myself, so this is 1/2 cubed, right? I could also think this is the same thing as 1 cubed over 2 cubed. 1 cubed's 1, 2 cubed's 8. Either way. So I'll get an 8 there. Add the 8. Multiply them. Okay, we'll see that? Multiplying fractions, right? Okay, so I've got, all told here, x to the 17th, y to the 5th, z to the 50,147, and
Over 8 times 3.
all over whatever 64 times 3 is. Yeah, how did I know that?
Because 1/8. Or do you mean like
You
having
guys want that trick?
Kind of. I'm gonna forget it.
I want 64 times 3, right? That's 60 plus 4 times 3. 180 and 12. It's 192.
And then
This is actually how Common Core teaches the multiplication method, which is way better for mental arithmetic. Super fast. This is also behind, when people are really good at multiplying numbers in their head, it's because they're good at doing this algorithm in their head.
And then is that done?
Yeah. And that is as simple as I can get it, right? Because I've got x's, y's, z's, and numbers. I can't combine those in any way because they're not like terms, right? That's cool.